Pre-statistics. Part 2. Formulas. We'll begin with an example. Example 6. Solve the Fahrenheit Celsius model for F. Convert 10 degrees Celsius to the equivalent Fahrenheit temperature. Number 3. Use a graphing calculator to convert 10 degrees Celsius, 15 degrees Celsius, 20 degrees Celsius, 25 Celsius, and 30 degrees Celsius to the equivalent Fahrenheit temperatures. So this is a literal equation. So we want to solve for F. So the first step is to get rid of the fractions. So we're going to multiply by the reciprocal, 9/5. This will cancel this fraction on the right hand side. So we're left with 9/5 times C equals F minus 32. Now we want to add 32 to both sides, and we're left with the equation 9/5 C plus 32 equals F. So Fahrenheit equals 9/5 times Celsius plus 32. If we substitute 10 for C in the formula and solve for F, we have 9/5 times 10 plus 32. 9 times 10 is 90, divided by 5 is 18. 18 plus 32 is 50. So 10 degrees Celsius is equivalent to 50 degrees Fahrenheit. Number 3, using the graphing calculator, we want to substitute the inputs 10, 15, 20, 25, and 30 for C into the formula. So we go to our y equals, we enter in our equation 9/5 times x plus 32, and then we use our table feature, and we can see here are the corresponding temperatures in Fahrenheit for the given Celsius temperatures. So just for an example, when it's 30 degrees Celsius, it's 86 degrees Fahrenheit. So in general, solving for a variable in a formula will not change the relationship between the variables in the formula. They may look different, but they are actually the same. Number 2, in general, to find several values of a variable in a formula, we usually solve for that variable before we make any substitutions, just like we did in the previous example. Example 7. The average fee to use another bank's ATM was $3.05 in 2007. The average fee has increased by approximately 7 cents per year since then. Let F be the average fee measured in dollars to use another bank's ATM machine at T years since 2007. Number 1, we want to find an equation of a linear model to describe the situation. Number 2, we want to solve the equation that we found in part 1 for T. Number 3, we want to estimate when the average ATM fee was $3.20. Number 4, we're going to use a graphing calculator to predict when the years the ATM fee will be $3.30, $3.40, $3.50, $3.60, and $3.70. Let's start with number 1. Since the ATM fees increase by 7 cents each year, we can think of that as a slope. For every increase in year, the y increases by 0.07. So since the average ATM fee was $3.05 in 2007, the f-intercept is going to be 0,3.05. If you recall, this is like our y-intercept, and our y-intercept is our beginning value. Putting these two values together, we come up with our linear equation. F equals 0.07 times t plus 3.05, where f is our dependent variable, it's like our y, 0.07 is our slope, t is our independent variable, and 3.05 is our y-intercept. Number 2, we start off with our equation. To solve for t, we need to get rid of 0.07 and 3.05. 3.05 is adding, so it goes first. So we do the opposite and subtract $3.05 to both sides of the equation. We are left with f minus $3.05 equals 0.07 times t. Last step is divide by 7 cents, and we have t is equal to f minus $3.05 divided by 7 cents. Number 3, if we substitute $3.20 for f and compute t, we have $3.20, which is our f value, minus the $3.05, and then we divide that by 7 cents, and we get approximately 2.14. Now if you remember, the units for t are years, so this is how many years beyond 2007. So this is about 2009. If we put this in our graphing calculator, x minus 3.05, and be sure you include the parentheses, divided by 0.07. We need parentheses because the 0.07 is dividing both values. Here's the corresponding t values, time. So if we look at the first one, when the ATM fee was $3.30, t was about 3.6, which rounds to about 4. So 4 years after 1997 would be 2011. Here's our last example. It involves handheld and game console video games. In table 11 we have the console and the handheld video game sales measured in billions of dollars in the United States for certain years. So we see in 1998 we had $3.7 billion. In 2006 it's $6.5 billion, and it appears that as the year increases, the video game sales increase. So let's let S be the console and handheld video game sales in the year that is t years since 1990. A model of this situation is S equals 0.39 times t plus 0.58. Use a graphing calculator to draw a scattergram and the model in the same viewing window. Does the line come close to the data points? B, we're going to solve this equation in terms of t. C, using the equation from part B, we're going to estimate in which year were the sales 8 billion. And D, we're going to use the table feature of the graphing calculator to predict in which years computer and video game sales would be 9, 9.5, 10, 10.5, and $11 billion. Let's begin with A. So we go to our graphing calculator. We have to hit our stat button and then hit enter for edit. We put our years since 1990 in list 1, our independent column, and then in our dependent column, list 2, we put the corresponding amount of sales. Next we hit the y equals. We put our equation into y1, 0.39 times x plus 0.58. The next thing we want to do is turn our stat plot on. So we hit second and y equals, which is stat plot. We hit enter. We first want to make sure that the plot is on. Then we want to make sure it's on scatter plot. And once the stat plot is on, we hit the zoom key, and then we look for zoom stat, which is number 9. What the zoom stat will do is it will create the correct window settings for our data that we put in list 1 and list 2. Here's our scatter plot with the given model. Part B, we want to solve this for t. So our first step is to subtract 0.58 to both sides. and then we want to divide by 0.39, and we have our equation. Part C. So cells S is going to be 8. We subtract 0.58, and then we divide by 0.39, and we get 19.03. So if you recall, T is how many years since 1990? According to the model, that the cells will be 8 billion in 2009. Part D, we're going to use the table feature in the graphing calculator to predict in which years will the cells be 9, 9.5, 10, 10.5, and 11 billion. So we go to the graphing calculator, we type our equation in. Again, we need parentheses, x minus 0.58 divided by 0.39. It might be a good idea to go ahead and turn the stat plot off, which you just use your right arrow key, hit enter, and that takes your stat plot off. Next you want to hit table, which is second in graph. Here we have the S values, and here we have the corresponding T values. Now if we want to pick certain S values, we go to table set, which is second, and window, and we change the independent from auto to ask. We type in 9 for X, and we get the corresponding T value. Thanks for watching.